Hello, everybody. Okay, today we'll be going through one exam paper from Hillgrove Secondary School 2021 paper. The paper is pertaining to 4 and 8, okay, the Sec 4 Normal Acad Science syllabus. Okay, I have shared the paper in my Google Drive. The link is below. Okay, you can click on the link below in the description panel. Then after that, you can download the paper. Okay, if you already have it, okay, I will also go through each of the questions in detail to see what are the common mistakes or what is the common solution that is given in the for that particular question. Okay, now for the paper, okay, paper one, we'll look at paper one first. Okay, paper one, okay, if you've done it already, okay, this is the answer for your MCQ paper. I will flash here for a while. Okay, those who have already done it, okay, you can pause the video and actually take a look at answer and mark your answer. Okay, take a look at what are the questions that you actually have problem with or make careless mistakes. Okay, now once you got the answer, let's move on to the questions in detail. Okay, now for the first question I would say is quite straightforward. It's a basic question of a scalar and vector question. What is a scalar? What is a vector? Okay, for vectors and scalar, remember the main differences between vector and scalar is in terms of its component. For scalar, it is only having magnitude only, no direction. Okay, magnitude only. So this is one of the reasons why the answer that I have for this question, density, is a scalar, because it only has size, okay, but no direction. Yeah, vectors, remember, vector is magnitude and direction. So for scalar, is the only have magnitude only, don't have direction. Now, for gymnastics, okay, question 2 is bouncing up and down. Okay, the question says that on the second try, it bounced actually higher. Oops, on the second try, it bounced higher. Okay, what changes on both occasions? Now, the acceleration of the object in air. Okay, now the gymnastic guy, the person is actually jumping in the air, is actually experiencing what we call free fall. So free fall, the acceleration in air is actually a fixed number, which is a equal to 10 meters per second square. So this number is actually fixed one. So this number is what we call a constant, so it doesn't change one. Okay, due to the gravitational field strength of the Earth, the gravitational pull. The weight of the object, no, the weight of the object doesn't change. Weight is controlled by the formula mass G. Okay, mass of the object, it remains the same. Okay, the person jumping on the trampoline remains the same, has the same mass. Gravitational field strength, which is 10 Newton per kg, it remains the same because it's on the same planet. So as a result, my weight actually remains constant. Okay, speed at the highest point changes. Now, the keyword that we look at is highest point. Now, when we look at jumping, we look at highest point. Highest point, there is a property. Okay, when we talk about highest point, there are a few properties that you need to take note. Highest point of the bounce, it has certain property. It means higher point, it means it has the largest distance. Okay, the largest distance from the ground. And at the same time, it also has the lowest speed. And how low is low? It is actually 0 meters per second. Okay, at the highest point, okay, you will find that the object actually stay there for a while. Okay, there is a split second that is actually 0 meters per second before it drop down, before it change direction. So when we talk about highest point, there are two things that students need to take note. At highest point automatically means the greatest distance from the ground, and it also means it has 0 meters per second. Okay, the speed is actually 0 meters per second. Okay, for highest point. So which means it actually remains the same, which is 0 meters per second. So it will not change. Now, the speed of the object at contact, get trampoline, definitely it will change. Why? Because based on the question, it says I jump higher. When I jump higher, it means the potential energy at initial, the first jump, and the potential energy at the second jump is definitely different. And in fact, how different? They will tell you is higher on the second try. Okay, it will mean that the potential energy for the second try will be higher. And what we look at is ideal cases whereby it will be potential energy is fully converted to kinetic energy. And kinetic energy, we all know the formula is half mv squared. Okay, so if the potential energy at second try is higher, it will mean that the conversion 100%, it will mean that the kinetic energy will also be higher. And at the same point, it also means that the velocity of the object actually is much higher at the second try. That's why the answer here will be D. Okay, so take note of what we are looking at. Okay, other than looking at finding the correct answer, we are also looking at how do you or how do I as a student actually analyze each of the option. How do I eliminate the false positive or the wrong answers from these choices he has given? Now, question 3, resultant force is F equal is 20 Newton. Okay, acceleration is 2 meter per second square. What is the resultant force? Okay, from the question that I have, okay, now the common thing that we are looking at is resultant force, which is F net, okay, equal to ma. Now, F equal to ma, at the first case, I will have 20 Newton. The mass unknown, but the acceleration given in the question is 2 meter per second square. Okay, if you do the algebra, you will find that my mass, I will be able to calculate my mass, which is 20 divided by 2, which is 10 kg. So the mass of the object is 10 kg. Okay, and same thing, the question asks, what is the resultant force when the acceleration becomes 10 meter per second square? Remember, the 10 meter per second square, although acceleration is different, but the mass actually remains the same. Okay, which is 10 kg. So use the formula, F net equal to ma. Okay, the mass is 10 kg, acceleration is 10. 10 times 10, it will be 100 Newton. So the resultant force will be 100 Newton, which is C. Okay. Question 4, mass changes resist change in motion. This is what we call inertia. Okay. So inertia, there's only one factor that that affects resistance, which is the mass of the object. Okay, resist change in motion, another name for it is inertia. So students, you have to remember, okay, what do I mean by a small portion of the topic, chapter 4, I think mass, weight, density. That's where inertia is. Question 5, the density of the object. Okay, common, I would say based on the table, I would say one of the common facts that physics students we have to take note is we have to be aware is that the density of the water is actually 1 gram per cm cube. Okay, just to have a rough idea of like how big is big, how heavy is heavy. Okay, so generally we take water as like a benchmark. Okay, so we know that anything more than 1 gram per cm cube definitely will sink in water. Okay, so take a look at, so if you look at it, you'll definitely find that if it's diamond, definitely will sink because density is more than 1. Lead definitely will sink, which is more than 1. So these two will sink in water. Okay, if you compare, so we do a simple comparison. We compare water with diamond in water versus lead in water. So we're looking at the bigger the number, how big is the number, bigger than 1 because it's water. Okay, and similarly, using the same principle, we actually can compare whether diamond, does it float in olive oil or does lead float in olive oil. Okay, it depends on the number. Okay, now 1 gram per cm cube. Okay, which of the following statement is correct? Okay, now 1 gram per cm cube is greater, 1 cm cube of diamond is greater mass than 1 cm cube of any objects. Okay, let's take a look. How do we look at this? How do we interpret the data? Diamond is 3.51 per cm cube. 3.51 gram per cm cube. It would mean that 1 cm cube, it will actually contain 3.51 grams of diamond. Okay, that's the mass of diamond that's given. Okay, that's how we interpret density. So definitely, okay, which our statement, 1 cm cube, there is 1 cm cube of diamond is greater mass than any of these substances. Okay, then you take a look, this statement will be wrong because why? Because for lead, 11.3 gram per cm cube, it means that 1 cm cube, the weight of lead available will be 11.3 gram. Okay, this number is definitely bigger than diamond. So first statement is wrong already. Okay, and similarly, okay, if you look at olive oil, okay, you do a comparison, you'll find that actually the correct answer will be 1 gram of helium. 1 centimeter cube of helium, okay, has less mass than 1 cm cube of every object. Same thing, let's take a look. Okay, helium, okay, 1 cm cube, it will have, whoa, so much 0.00 0.018 gram. Okay, this number is definitely the smallest in this table. So definitely 1 cm cube of helium will definitely be the least, will definitely be the lightest, okay, among the table. So that's why answer chosen is B. Okay, if you use the same principle as what you done in A and B, you will find that C and D will also be eliminated as false. Okay, so check your answer and check how we analyze the table based on the basic concept of density, gram per cm cube. Okay, the mass per unit volume. Now, the vase stops at the surface, okay, before falling down. Where is the center of gravity? Now, center of gravity based on this shape is a regular shape. I would say it is definitely in the middle, like what the question mentioned now, is definitely in the middle. Okay, definitely in the middle, because in the middle line, okay, all the object or the masses on the left, okay, it actually balance off with the mass on the right. So this is what we call center of mass or center of gravity. Now, what happens to the horizontal? This is the what happened to the top and bottom. Okay, so I would say I would say that the mass of the object and center of object will be roughly here. Okay, it will be roughly here. Okay, why would I say it's roughly here? Because, okay, the top part of this object would roughly be having the same mass as the bottom of this object. So center of gravity is what we call center of mass, whereby the point whereby all the masses are actually equally distributed. So that's why the answer for CG here would be actually C. At point C, the mass of the object is actually equally distributed on both sides, on all sides, to be exact. Question 7. No, question 7, I don't have the question, but I believe it is a clockwise equating clockwise moment. Okay, once I have the questions, I will get back to you. Now, question 8. Question 8 is a common question. I've done it. I think I've done it in the prelim paper. I think quite similar to. Okay, now when I squeeze the finger, I squeeze the pin between the thumb and the finger. Okay, common things that you take note is the area here. The area here at the finger, okay, is actually much larger than the area at the thumb here. Okay, the area at the thumb. Okay, because why the pin is actually a sharp pointed edge, which means if I exert the force, get on the pin, okay, if I exert the force on the pin head and it transfer to the pin, okay, if I apply the same force, okay, on the pin and the force on the head, the force on the head, the force on the pin, okay, if they are the same force, you'll find that the pressure at this area, the pressure at the head, okay, will definitely be much smaller as compared to the pressure at the pin. Okay, why do we say that? It's because pressure is controlled by two factors: force over area. Okay, force over area. Okay, if I apply the same force for both of them, the numerator is the same. But what happened now is that my denominator, my area for the pin is actually smaller. Okay, the area is smaller as compared to the area at the pin head. So you'll find that the fraction or the ratio here would definitely be much larger at the pin as compared to the ratio or what we call the pressure at the pin head. Okay, that's why the pressure at both sides, okay, the pressure at both sides here will be, the thumb will be actually, what did I mention? Give me a minute. Oh, which statement is wrong? Sorry, which statement is wrong? So the statement that is wrong would definitely be B. Okay, wrong. So because the pressure at pin is larger, the pressure at head is smaller. So that's why the pressure at both sides would never be the same. So that's why the answer I choose is B. Okay, pressure at the thumb and the finger is actually the same. They are not the same. Okay, because the area is different. So that's why the pressure will be different. Now for 9, conservation of energy. Okay, well, I would say it's quite a straightforward answer. So I would say everybody should be able to do it. Okay, now number 10, the person does 200 joules of work each time he lifts a weight. Okay, in 5 minutes, the average power is 50 watts. So one lift is 200 joules. So if I want, how many leaf can I do in 5 minutes? Okay, remember, how many leaf I can do in 5 minutes? So power is controlled by energy divided by time. Okay, so the power that's given by in the question, the power of the person is 50 watts. Okay, time given is 5 minutes. I will do that for 5 minutes. But remember, when you use the formula, you have to convert it to SI unit. So you have to multiply by 60. Okay, now each leaf is 200 joules. So I will definitely need to do a few more. So let's say I call this n times. Okay, so it will be a number of times that I leave. So that will be the total energy. So each leaf is 200 joules. I make n times of the leaf. So 200 times n will be the total energy spent. So if you look at the math, okay, so it'll be 50 watts times 5 times 60. You look at algebra, divided by 200. Okay, if you press your calculator, you'll find the answer will be 75. Okay, usually I would say that even like before you do the question, you actually know already. For this type of question, most likely I will be able to eliminate straight away 1.25, because where do I, if a leaf is a leaf, it's not possible to say I had leaf 1.25, 1 1/4 way, where I leave one time and maybe a quarter I stop it. Okay, it's not really possible, because for a leaf to be completed, it has to be it has to be a complete leaf. Okay, so 1.25 will definitely be out with decimal place. Okay, so but what happened? B, C, D, will I be able to eliminate answer without doing working? Sad to say, I will not be able to do that. I will still need to rely on my math to get the answer. Okay, so that's why the math and formula is actually important. Now for 11, okay. Now for 11, okay, you'll find that the question here is a sealed container. Okay, a sealed container. Okay, sealed container have a standard formula. Okay, so now what happened is, if the molecule of the liquid in the sealed container, what will happen? Okay, the sealed container, same temperature, everything, nothing changed, same. So they will definitely be moving in random direction. So this will be definitely be correct. Now the molecules of the liquid, right? I will eliminate A and B straight away. They will not be moving at same speed. Each of the molecules will be having a different speed. But what will be more correct to say that is the average speed of the molecule would be the same. Okay, if nothing changes, temperature don't change, everything remains the same, fixed volume, everything, the average speed actually remains the same. For this object, the average speed of the molecule will be the same. Okay, if no temperature changes, the keyword here is average speed, because there are a lot of molecules in the container. Okay, how much more is that based on Avogadro constant? Okay, it's a lot more molecules. So it's impossible to virtually have all the molecules having the same speed. Some will be faster a bit, some will be like changing speed, some will be experience different thing in that whole system. But as a whole, I will be able to conclude that there is an average number. So if I take up the average, if I sum up all the speeds, I divide by the number of molecules inside, I will definitely have a number, a speed, a representative of that whole particle. And that representative is what we call the average speed of the object. So that's why A and B is wrong. A and B, the question is referring to each of the molecules moving at the same speed, which inherently the statement is wrong already, because there are too much molecules inside the system to actually control, to have the total speed in the system to be the same. So if the question were to say the average speed is the same, that would be a correct statement. But if based on A and B, I'm talking about the each individual molecules are having the same speed, that statement is wrong. So that's why I will eliminate A and B. So you only left with C and D. Temperature increase. Okay, temperature increase, what will happen? If the temperature increase, the most straightforward that we have based on your property of molecule, it will be the kinetic energy of the object actually increases. Okay, and the speed of the molecule actually increases. The distance, or what we call the intermolecular bonds, okay, it doesn't change. The intermolecular bonds, okay, intermolecular bonds, when will it change? When I change state. Okay, distance between the molecules, or distance between the molecules will only change when the object, or when the state is changing from liquid to gas, or from solid to liquid when it's melting, or when it's boiling, okay, or it's melting or freezing, or this. When there is a state change, the distance, intermolecular distance between the particle will change. That's why if only temperature change, okay, the distance between the liquid actually will remain the same. That's why my answer will be D. Okay, so this is how I eliminate each of the option here. Okay, by knowing what happens to the kinetic energy, the potential energy in the molecules. Okay, 4 identical copper. Okay, take note, 4 identical copper. Okay, copper identical. Okay, then after that, the object, the liquid is at 80 degrees Celsius, so it's what we call hot. Okay, after 5 minutes, which container will have the coolest water? Coolest water means what? Coolest water here means I cool down the most. So I definitely have to lose the most heat. Okay, so how do I lose the most heat? I will definitely need, okay, the lid to be off. Okay, so A and D will definitely be out straight away. Okay, why? Because with lid, I can allow evaporation, I can allow convection current, and it's 2 additional methods to lose heat. So definitely B and C, A and B, or C and D, B and C will definitely be much faster if compared to A and B. Now, here what happened is at the surfaces at poly surface and dull surface. Okay, this is where we look at your color. Okay, the color of the object. When we look at the color, we definitely refer it to radiation. And radiation, we all know that radiation has one property, which means the black object will definitely radiate the heat the fastest. So that's why I know the answer will be C. Okay, because C, okay, no lid, there is convection current, there's evaporation. And when it is a black coating, black means it's a good emitter. So definitely I will have a much faster heat loss as compared to option B. Okay, that's why the answer is C. Now, when your liquid evaporate and escape, what happened to the temperature of the thing? I will say this one is a very standard MCQ question whereby the students need actually know what happens during evaporation phase. Okay, remember evaporation is the losing of the particles only where? Only at the surface of the liquid only. Evaporation only occur at the surface of the liquid. So if you get your facts right, you'll find that A and C is the only answer that could be. So B and D automatically I eliminate straight away. And same thing, what we have for evaporation. Another name for evaporation is what we call the cooling effect. Okay, so when evaporation occurs, there will be cooling effect, which means that the temperature of the object, okay, cooling effect. So the temperature of the object will definitely be lower. Okay, so that's why I will know the answer will be A. Okay, so take note of it. Now, for speed of the wave, okay, speed of the wave, okay, the distance between the particles, okay, with the wave front, all these things. Now, speed of the particles, okay, speed of the particle usually refers to wave V. The formula we have is V equal to F lambda. So if I want the speed, I would definitely need to know the frequency. I would definitely need to know the wavelength. Okay, so how do we classify wavelength? Wavelength, how do we classify? There's a few way of writing it. It's what we call crest to crest. There's one perfect wavelength. Or sometimes we call this wavefront to wavefront. Crest is what we call, okay, you can actually label it as wavefront, okay, to wavefront. Okay, the distance between the two wavefront will actually be the crest of each of the wave. So it will be actually eventually it means the same thing to be crest to crest. Okay, so that's why that's one way. Okay, for me to know the velocity of the wave, I definitely need to know the frequency, or what we call the inverse of the period, or what we call in frequency refer to 1 second, how many waves do I generate. And after that, the second factor I need will be the wavelength, okay, the crest to crest, okay, which you based on this option here, definitely will be D only. Okay, because remember, I need wavelength. Wavelength is always crest to crest. So this answer will be wrong. Okay, so the distance between wavelength and crest, okay, within crest and crest, this also means crest to crest, definitely. But the problem is, remember, when we talk about frequency, we need the second factor. We need the second factor, which is your frequency, which is your time, okay, or your frequency or hertz. Okay, we will need some aspect of this factor here. And you know that part A, nothing mentioned about time or frequency. So that's why although A looks almost correct, but it's not the complete truth. So that's why A is out. Okay, said likewise for B also. Okay, the crest is what we call wavelength. To find the frequency, I definitely need the wavelength, which is from crest to crest, trough to trough, or even wavefront to wavefront. Okay, so that's why my answer is D. Distance or the particle move up and down. No, up and down usually refer to transverse wave. It has nothing to do with the motion of particles. Okay, it has nothing to do with the speed of the wave. Okay, so that's why my option is D. 15 EM wave. I will not go through too much. This one is basically you have to remember what are the what was the wave in the electromagnetic spectrums. Okay. Speed of the sound in air when an object. Okay. Now, when the boy at 350, okay, from the girl hear the bang 1 second apart. Okay, here I would say the drawing actually is the most important one. Why did the boy hear two sound? Okay, it's because the sound at the first glance, okay, first bang, the first sound that the boy hear is actually from the girl to the boy. This is the first sound, which travel 350 meters straight away. The other one that we look at, the second sound that the boy hear is because of the second sound, the girl will travel to the building first. Then after that, they will actually reverse, reflected, and go to the boy again. So the boy will hear the second sound now. Okay, so between the first sound and second sound, okay, you'll find that this sound, the wave actually travel an extra distance of 165, another 165, thereafter another 350. Okay, so to travel this amount of distance, to travel this 165, to travel this 165, and to travel this 350. Okay, it will literally take me 1 second. So I will know the total distance travel and I will know the time span, which is 1 second. So I will definitely find the speed of the air itself. So distance divided by time, so you'll be 165 plus 165. Okay, this and this plus 350. How long do I need? 1 second apart. Okay, so with this number here, you will be able to calculate the answer, and you'll find that the answer here will be A, 330. Okay. Sometimes I would say that if you are urgent, let's say if you're only running out of time or this thing, you only got like the last 10 minutes to do and you can't really complete the working, I would say just speed of sound in air, which we all know that is roughly a constant of 300, 330, 340 meters per second. So I would say that the answer for part 16, question 16, if you look at eliminations, I will be able to eliminate C and D because I know the speed of sound in air is 350 and 330. Depending on where you sit on this thing, depends on what happened to the situation. So that's why I still need my math. Okay, I still need my math. Okay, to work out the answer for me, so that I can actually eliminate 350 for me. Okay, that's one of the best thing about math is that math will actually help us to solve the thing. Convection flow and electron flow. Okay, this one is what we know. Okay, convection current flow is from positive terminal to negative terminal. Okay, electron flow will be from negative to positive. Okay, so this one I would say is quite straightforward. I will not go through it. Okay, just know the direction. Now, number 18 here, we are looking at is your, sorry. Okay, number 18 here, we are looking at four resistor. Okay, so if you are able to see this equation, you can actually redraw the thing. I will lengthen this piece of wire, lengthen it up so that it looks like this. Okay, so this is the circuit that you are looking at. Okay, so what did I do is I actually lengthen the wire here, which is here. I lengthen it so that the resistor is all on the straight line, is easier to see lah. Okay, now The ammeter reached 4 amp. So where is the 4 amp now? The 4 amp is here. Okay, the 4 amp is actually here. So the current here will be 4 amp. Okay, remember here, we are looking at, for now, this is a series here. It will be 4 amp here. It will be 4 amp after I go through the first resistor. So this is 4 amp. Then after that, I have a parallel resistance. I have a parallel circuit arrangement. So you'll find that some current will be on top. Some current will be below. Okay. So you'll find that on top of the branch, okay, on top of the branch, okay, so the current will split. Then after that, they will merge back again. Okay, so this will be 4 amp again. Okay, so in fact, okay, if the ammeter reach 4 amp, if this is 4 amp at the beginning, which of the circuit will have less than 4 amp? Less than 4 amp, definitely, if you look at the arrangement, less than 4 amp, you actually definitely means IC or I. Okay, so they'll be less than 4 amp. Okay, it will definitely be option C. Okay, so that's how we look at a simple circuit like this. Circuit breaker, okay. Okay, circuit breaker is like a switch like that, okay. It allows me to actually switch off, okay, to trip, okay, by tripping, okay, to switch off the circuit when there's excess current. Okay, now the combination of heater is by one switch. The heat unit is 2000 watts and 20 watts. Okay, 1 week, the lamp use 1 kilowatts. Okay, remember 1 kilowatt hour. Huh? How much energy is used by the heater alone? Okay, so now take a look. Heater is 2 kilowatt. Oopsie. How much energy? Okay, now if you look at kilowatt hour, okay, or to be exact, this is kilowatt in 1 week. Okay, this is what happened here. Okay, for this question here, you have to take note is that whenever the lamp is switched on, the heater is switched on also. Because why? Because the question said they are controlled by one switch. So if I say in 1 week, right, the lamp uses 1 kilowatt hour. So in 1 week here, if you look at the formula, energy is power times time. Okay, so in 1 week, okay, in 1 week I will not know how long have I used the lamp. It doesn't mean it's 24/7. So it doesn't mean every day, every night is opening. So I need to know the exact timing. But once I know that the time I spend using the lamp, I will be able to find the time I need, okay, time I spend for the heater. Okay, so what happened now is because at this instant I will have, this is my lamp. Okay, now at the same time for my heater, okay, it will also have it will use a certain amount of energy, power, and time. Okay, so if this is heater, the energy used by heater. If this is lamp, this is the power of the lamp, energy of the lamp. But one thing common among them is that the time between them is the same. Okay, the time between them is the same. So I would definitely need to know the time first. Because why? Because the question asks for the question asks for the energy by the heater. So to find EH, I would definitely need to know the time spent first. Okay, so where do I get the time spent for the heater? I will need to find the time spent on the lamp. Because the lamp and heater, they are both operating at the same time. Okay, so same thing. The lamp given is 1 kilowatt hour. Okay, remember, if you're using 1 kilowatt hour, remember the time has to be in hour, the power has to be in kilowatts. So in this case, for the power of the lamp is 200 watts, so it will be 0.2 kilowatt. Time taken here will be in hour. So if you look at the math, it will be 1 kilowatt divided by 0.2. Okay, give me a minute. 1 divided by 0.2, it will definitely be 5 hours. Okay, so you'll find that the answer will be 5 hours. So effectively, in 1 week, I use the lamp for 5 hours. So which will also be the same time that I use for the heater. So the heater will be 5 hours. The power of the heater will be in kilowatt also. I remember in kilowatt. So it will be 2 kilowatt also. Okay. Then after that, 2 times 5, it will give you 10 kilowatt hour. Okay, the energy used by the heater, which is 10 kilowatts, which is option A. Okay, so that's where I get my answer to be option A. Okay, so this is where this is so much for the MCQ. Okay, remember, if you need the MCQ answer, just pause and just go back to whichever question you need. If you need the section B, paper 2, section A or section B, okay, just pause the video and just go to the respective location. Okay, you don't need to watch through the whole video. Okay, so now we will proceed on to the paper 2. Okay. Now for paper 2, okay, the first few questions I would say is quite straightforward because there's helping words given, so I will not dwell too much. Okay, so if you need the answer, I'll just pause here. You can just pause here and take a look at the answer. Okay, now for question 3, right? 3 will be an interesting question. Now, to find the CG of the object, right? What I would suggest students to do is by dropping vertical lines. Okay, so for example, right, if I'm given the shapes, so let's say, where do I get a shape? So if I'm giving a triangle shape, okay, so now how do I find the perpendicular shape, the CG of this object? So what do I do now at the beginning is actually, for each of the vertexes, okay, for each of the point or vertex, okay, the corner here, okay, the corner, for each of the corner of the okay, for each of the corner of the triangle, okay, for each of the corner of the triangle, I will drop a vertical line. Okay, so example for the first one, okay, I will draw a vertical line down, okay, all the way, okay, vertical line. Then what I do is, I will just keep this. Then what I will do is, I will actually visually, okay, rotate it, okay, not rotate it 90 degree. Okay, then after once, if I rotate it 90 degree, okay, let's say 90 degree, this is what I get. So what do I do now is, I will actually take another vertex, okay. So let's say, can I rotate it better? I just rotate it at the another vertex. Okay, okay, I will use this. Oh, sorry. Okay, so now what happened is, oh, sorry. Okay, so now they're together. Can I group these together? Oh, I can't group these together. Okay, I'll rotate both of them together again. Okay. Oh, see, no, I can't. Okay, so what I do now is, I'll take a ruler, I'll draw a vertical line from the vertex. Okay. So vertical line from the vertex, drop down. Same thing, I will start and do the other vertexes. Okay, the other vertex which is here. I'll drop a vertical line down towards the opposite end. Okay, and all the 3 lines will actually intersect at a particular point. That point is what we call the CG of the object. Okay, usually what we do is we drop a vertical line down, okay, to the opposite edge. Okay, so for example, I'll drop from this vertex. I'll drop a vertical line to the opposite edge. Okay, so I'll do drop opposite line to the opposite edge, and after that, I just keep repeating it for different vertexes. So if I have 5 points, as I have 3 points, I'll have 3 lines. So let's say, example, if I have 5-sided shapes, okay. So let's say, for example, I don't have 5-pointed shape. So let's say I draw it, okay. So let's say I have a 5-pointed shape. Okay, so what I do now is, I will actually use a ruler at each of the corner, at each of the point, I will actually drop a vertical line to the opposite side. Okay, a vertical line to the opposite side. Okay, so this is what I do. Okay, I'll drop it down. Okay, here you go. Yes. Okay. So I drop it down. Okay. So at each of the point, I will drop each of the point, I will drop a vertical line. Okay. Same thing at each of the vertexes, I will drop a vertical line to the opposite edge. Okay. And the intersection point between all the line will actually be the CG of the object here. Okay, this technique is of finding CG, I would say it's a small technique that each and every one of us should know. Okay, because it is actually an effective way to locating the CG of any given shapes, okay, by using drawings. Now, why the CG of the car should be as low as possible? I would say it's a straightforward answer, because remember, why do we want CG to be low? Why do we want the CG to be low? Why do we want the base to be broad? Okay, broad base. Okay, why do we want the base? Why do we want the base to be broad, CG to be low? Okay, the only one reason, okay, because we want the object to be as stable as possible. Because the broader the base, broad base, okay, and low CG, the broader the base, the broader is the base, okay, the lower the CG, the more stable it is. Okay, so these are the two factors, or two important factors when we talk about CG. How do we sorry, not CG, talk about stability. Okay, for the object to be stable, the CG has to be low, the base has to be broad. Okay, these are the two main factors that we look at. Now for surfaces, question 4, the important thing I would say the question look at is the surfaces, the color. Okay, silver followed by dull versus shiny. Okay, so it would be a classic example. If you look at this factor, you look at the color itself. This is color. Dull and shiny referring to the texture. So color and texture definitely refer to the process of radiation. So that's why you know definitely the answer. The question is going to revolve around will be on transfer of heat, particularly on radiation, because that's the factors that are given to them. Okay, interior of the car race faster, increases. P and Q, which one raise more quickly? Definitely you will know that the answer has to be P. Why? Because when we look at radiation, the radiation factor is black is always a good absorber and a good emitter. And when we talk about black, we have dull surfaces, big surfaces. Okay, these three factors, okay, is what determine the object has to be a good absorber or good emitter. Okay, black is always the best, dull is always the best, and big is always the best if you look at absorber or emitter. But of course, remember, when you look at emitter or absorber, at any time, any point in the question, students, you have to decide on one factor. The object has either to be absorber or has to be emitter. So it depends on the question. In this case, based on the question is that the sun is coming from the outside. So the sun is coming from outside. So which means the object has to be, okay, absorbing heat from the environment. So the heat is from the outside. The environment is actually hotter than the car itself at the beginning. So at the beginning, okay, the car is actually cold. Okay, outside is actually hot. Okay, so heat always travel from hot to cold region. So it'll be from outside to inside. That's why we're looking at absorber. Okay, so and same thing, if we talk about transfer of heat, there are certain keywords that we talk about. Okay, so you must state what is the mode that you're using, which is absorber or emitter, depends on the question. In this case, it is a absorber. So you have to write absorber first. Then after that, you have to write which is better. Okay, remember, black, dull, big is always better. Okay. Now, so remember, you look at the keywords. When you write the keywords, the first statement that you must write is you must decide what mode first. If you are like, let's say you want to add more, just to be clear, you can continue on to say black is a better absorber. Okay, you absorb heat at a faster rate. So you absorb heat at a faster rate. So if you want to like make your sentence clearer, okay, you can continue to say I absorb the heat faster. Okay, but take note, the sequence of answer, it has to be, the student need to state which mode first. So mode is definitely, you must write. Then follow, you want to make it clearer, you can tell me faster rates, okay, absorb heat at a faster rate. So definitely the mode you have to write. Okay, the second sentence, absorb heat at a faster rate, it depends on the question. But if I were you, I'll just write both statements to be safe, to be clear. Okay. Question 5, okay, the component for gamma, microwave, the users for gamma ray, X-ray, infrared. Okay, this one I will say just you have to refer to the notes or your textbook to know what are the factors. Okay, now section B, Okay, section B, wavelength, amplitude. Okay, know where they are in terms of labeling. So you need to be well versed of the the shapes. Okay. Now, when we part B is the one that students have to be careful. When we look at this type of shapes, it actually refer to what we call the pitch and loudness. Remember loudness of the object. Loudness of the object. Okay, refer to amplitude. Okay, pitch of the object refer to frequency of the waves. Okay, so these are the things that you need to take note for small components of the waves. For sound wave, you look at the keywords. Whenever I would just always remind students, whenever you talk about loudness, okay, remember to bring in the word amplitude. Okay, these two words are always tagged together. So these two words is always like hand in hand. So whenever I write high pitch, I will also just continue on to say it has a higher frequency. Okay, high pitch, high frequency. So these two words I'll tag together. Okay, because sometimes the question require maybe just students to state pitch. The marker doesn't need the students to talk about frequency, but sometimes it's the reverse. Sometimes the marker need students to talk about frequency, but not much on the pitch. So to play safe, just write both. Okay, and it's just a short sentence anyway. Okay, so part B. Okay, based on the question, part B, the question says based on part B1, it says a louder sound. Louder sound only. Okay, when you talk about louder sound, like I mentioned before, this guy refer to amplitude of the object actually increases. That's all. There's no mention of frequency, so I will safely say the frequency remains the same. So which means that the wavelength at the period and the frequency actually remains the same. So the frequency or the period, okay, remains the same. So which means that where I cut the wave, where I cut the equilibrium or the zero axis, zero point is always remaining the same. Meaning at trace A, it cuts the waves, cuts the oscilloscope at this point. So if you draw trace B having the same frequency, which means the cutting will actually be the same. You will cut the wave at the same point. Okay, the period will remain the same, or what you call the frequency remain the same. The only thing changes is actually the amplitude. Okay, the amplitude. Okay, which is why the trace B will actually look like this, because the question says louder sound, which is higher amplitude, but no mention of frequency. So I can actually safely assume that the frequency remains the same. Okay, so that is your trace B. Trace C, take note, trace C. Okay, trace C, the common thing for trace C, take a look. Okay, for trace C, the amplitude is the same, which is at 1 square here. So straight away, you can see that trace C, if you look at trace C, the amplitude of trace C and the amplitude of trace A, they are actually the same. The only thing that's a slight difference here is the periods. Okay, you look at for trace A, okay, it cuts one cycle actually is one cycle of this wave actually 1, 2, 3, 4 is 4 square. So this is actually one period, which is one cycle. Okay, but on the other hand, if you look at the trace C, one cycle is actually 2 square only. Here. So this is one cycle of the waves. For trace C, trace A, one cycle of the wave is look like this. Okay, for trace C, one cycle look like this. Okay, one cycle of the wave look like this. Okay, so the one cycle for trace C is actually taking a shorter time as compared to trace A. So no matter what you look at it, you'll find that actually trace C is so-called shorter, okay, as compared to trace A. So you'll find that the frequency, okay, of C and frequency of A will definitely be different because the period is different. Okay, and how big different is the frequency of C is actually larger than A. Okay, so when I talk about pitch of A and C, if C has a higher frequency, aka it will mean that the pitch at C will definitely be higher than the pitch at A. Okay, so this is how I deduce the characteristics of trace C. I look at the amplitude, I look at the frequency. Why do I look at amplitude and why do I look at the frequency? Because I know that for sound waves, okay, sound wave, I have two properties which is controlled by loudness and pitch. And loudness and pitch controlled by amplitude and frequency. So that's why for sound wave, I will know that I will want to look at loudness, to investigate about the loudness, investigate about the frequency of the wave, because it gives us two important factors, loudness and pitch. Okay, so that's why I will be able to get my answer to be A is lower pitch than C, or what I will call C is higher pitch than A. Okay, look at how I work towards the answer. Okay, I do it such that I put myself at students' shoes to see how, with my knowledge, how do I narrow down on the particular answer? How do I narrow down on a particular topic, particular concept, particular answer? Okay, by knowing what the question is asking for. Now, part C, okay, plotting a graph is straightforward. The only thing is take note is it has to be a curve, because the point given is a curve. Okay, then at 7 meter, okay, it's a straightforward of looking at the graph. At 7 meter is here. Okay, the answer will be here, which is somewhere here, which is 88, I think, if I'm not wrong. Okay, so it depends on your graph. Okay, part D, looking at the Part D, is a description question describing how you calculate the speed of sound. Okay, now here the question is LED. Based on the question is LED light will light up when a short pulse of wave is produced. A short pulse of sound is produced. Sorry. So you have to take note is the idea of why do I give you LED light? There is a purpose one. Okay. Now to calculate speed of sound. Okay, to calculate speed of sound, I will need distance divided by time. Okay, this is the speed of the sound. I will need two factors, distance and sound, time. Distance, straightforward, because if I get a measuring tape, I can measure the speed, I can measure the distance. So this way is straightforward. Okay, I will measure the distance straight away. But how do I measure the time? This is where the LED come in. Now, if you are far away, let's say 400 meters or 300, maybe 1 kilometer away, okay, how do you know that the sound wave has been emitted? Okay, that's where the LED come in. Okay, the moment I see that the LED light up, I will know that the wave has been emitted. So that will be my time 0. So that is where I actually start my stopwatch. Okay, to start, that will be a time 0. I will start straight away the moment I see the LED light. Then when I hear the sound, I will actually stop my stopwatch. I will say this is quite straightforward. So students, you have to be careful is why do I give you an LED light? Okay, the LED light has a purpose. The purpose is to signal to the timer that the sound has been emitted. Okay, so this is one of the primary thing that you have to take note of the questions that's given. Okay, this is one of the reasons why they give you LED light. Okay, then after that, once I have the time, okay, I will actually record the time, and with the formula, I will be able to calculate distance divided by time. Okay, so these are the things. If let's say if you want to like improve on the results, usually the question will say, suggest one improvement. Okay, so this is where you end off. Now, what happens is if I ask for improvement, okay, improvement, I will say one of the easiest way to do is actually, okay, record a few set of data, a few more set of data. And importantly, take average. Okay, once you have the average, okay, average this the average time taken. Okay, calculate the average time. Okay, for each of the distance. Then after that, you will be able to find the speeds of the sound with more accuracy. Okay, if you look at recording it a few more sets, of course, the main keyword is record a few more sets. Okay, so instead of taking one set, okay, you take 2 set or 3 set. Then after that, students, you must remember, taking more set doesn't mean accurate. What make it accurate is because after taking a few more set of data, you actually take average. Okay, finding average, eliminating any possible error. Then after that, you will be able to calculate to get a slightly more accurate answer for the speed of sound, okay, that the question needs. Okay, so if you look at improvement, quite straightforward. The easiest one will be just recording it for a few more times and the average. The last question here we look at, okay, is on a practical electricity, the line circuit diagram that we have. Now, take note here is on the wire X, Y, Z. Okay, just a small thing to take note is where it is being connected. For example, wire Y. Wire Y is connected where? Connected to the casing. Okay, remember to read the picture first. Okay, a lot of students who attempt this question, okay, someone who attempt this question did not read the question. They just assume X, Y, Z, they are just live or negative wire, positive wire. Okay, they fail to see where the wire is connected. Okay, so I would know that Y is connected to casing, so I will know that this is actually what we call the earth wire. Okay, and I will also know that X, okay, there's a fuse, there's a switch at wire X. Okay, so if there's a fuse, there's a switch, I will definitely know that X is actually what we call a live wire. Because live wire is where I put my switch and where I put my fuse there. Okay, so if I know X is live, Y is earth, I will definitely know that Z is what we call the neutral cable. Okay, so this is how I actually read the diagram and actually get my answers before I even read the question. Okay, remember to read the pictures, read the graph first. Okay, it has a certain meaning. Okay, so I think with all this, part A is out already. You have done it. Okay, why? Okay, and I also have explained why I know why is an earth cable, because it's connected to the metal casing. Keyword, remember, metal casing. Okay, now switch is closed, calculate the current. All right, I would say it's quite straightforward. Okay, any of the object here, you will say that if I'm looking for heater, if I have the power, if I have the potential difference, I will be able to calculate the current in the heater, okay, by using the formula P equal to IV. Okay, I'm given the power, which is here, 2000 watt. I'm given the potential difference, which is here. Okay, so I will be able to calculate the current. And similarly, for kettle, I will be able to calculate the current in the kettle also. Okay, because of power equal to IV. So I will be able to calculate the current in the kettle, current in the heater also. Okay, so this is where the formula come in, power equal to IV. So formula wise, for calculation for power, you have to remember them. Okay, for circuits, there are a few formulas, V equal to IR, power equal to P equal to IV, or sometimes resistance is rho L over A, current is Q over T. Yeah. So these are the formulas that you have to remember in order for you to work out your circuits. Now, if I know that the kettle is 1.25, so kettle is, let me do 12.5, sorry. So kettle is 12.5 amp. Okay, so this is the current flowing through 12.5 amp. Okay, then based on the question, I will say that the heater has 8.3 amp. So I will say the heater has 8.3 amp. Okay, so 8.3 amp is in this cable here, in this current here. Okay, and let me use a different color first. Okay, so the red one is referring to kettle, the green one refers to heater. So all this current, okay, all this current come from where? All this current come from wire X. Okay, so my current will actually come from wire X before splitting up to current at the kettle, and some of it will go to the current at the heater here. So from my live wire, I actually will split to two paths. One will go to the heater, one will go to the kettle. So effectively, I can say that, okay, with my heater is 12.5, my heater is 8.3, my kettle is 12.5, I will have a total current of 20.8. This is in the live cable. Okay, and live cable is where F1 is. F1 is where the fuse is. Okay, live one, this is where the fuse is. Okay, so if I have a current of 20.8 in the live cable, okay, I will definitely know that the current is definitely higher than the fuse rating. Okay, look at the keyword, higher than fuse rating, and because of that, my fuse will melt and it will overheat. Okay, remember for fuse there is a rating, and the question says the rating is 15 amp. Okay, so if your current is 15 and above, the fuse will melt straight away, and your circuit will be disconnected. Okay, and the whole circuit will not be functioning. Okay, and that is why I know that the fuse will melt. Okay, what are the possible things? Okay, double installations. Okay, certain appliances don't need earth wire. Yeah, definitely. Why? Because I have double installations. Okay. Part D, nothing much. Okay, part D, recording a time, setting in the correct interval, table interval. I would say it's not complicated. Okay, just need to set the table in the correct format. In terms of this question, the common mistake I have is in the formatting. Okay, the headings here, okay, take note, it has to be /unit, not bracket unit. Okay, so take note of what are the symbols, what are the presentation you need for the table. Number 8 here, okay. Number 8, if I know, is the last question already. Number 8 is the last question. Now, number 8 is a false question. Is it the last question? Yeah, it's the last question, okay. Now, number 8 is a false question here. We are looking at, okay, down F and R, okay, I would say it's a straightforward, it's a force and air resistance. Now, here, you have to be careful is how to read the question. Now, for this parachute question, right, you are given the speed here. Most of us know that this is where the parachute is dropping, the parachutist is dropping. Now, we also know that in this area, the parachute is in the air. But what differentiates between each of the section? For example, right, in this area, in this section here, okay, in this section here, the parachutist is dropping down. In this case, right, you look at the speed, how the speed is increasing. It's actually at a very fast rate. It's actually increasing already. And you'll find that if it's increasing, right, it will hint to me one thing, that is the parachute has not been deployed. Okay. Then after that, what happened is in the second phase, okay, there's a phase here whereby suddenly the parachute start to drop. The speed start to drop. Okay, until 20 seconds, whereby the speed will be the lowest. Now, the moment the speed starts to drop, okay, it will mean that why does speed start to drop in the middle of the sky when you are actually dropping down so fast? There's only one reason. The moment the speed start decreasing at this point, means your parachute, the parachute is 100% deployed. Okay, if not, you won't be able to reduce the speed one. Right, so the moment the speed starts to drop, the instant you see a drop in speed, the only reason you have for this parachutist to drop in speed is only one thing: the parachute has been deployed completely. Okay, once you deploy the parachute, you open straight away, and the moment you open, what's the impact? The speed will start to drop. Okay, then after that, the parachute will drop, the speed will start to decrease. So the moment I 100% deployed, the speed will start to drop, and eventually the parachute is deployed, and eventually at this point, the parachute is still deployed. The parachute is still deployed here until here. Okay, so the parachute is deployed 100%. Okay, then it will travel at a constant speed, or what we call terminal velocity. There's a word for it called terminal velocity. Then after that, suddenly you'll find that the speed suddenly dropped from maybe 5 or 7 meters per second, drop away to 0. What actually happens? Okay, there's only one thing. For your parachute to stop or to reach 0 meters per second, it only means at this point, the parachute actually has landed. Okay, he has completed his jump. He has landed on the ground safely. Okay, so this is what you should actually look at. What you should actually decipher when you look at the graph. What are the different motion that you have from the parachutist, and what are the possible actions that the parachutist is actually experiencing? And with that, you actually can straight away, you actually answer most of the question at the bottom already. So look at the question: when is the parachute fully deployed? Fully deployed is here. okay, which is times 7. Okay, look at the graph. And what is the speed of the parachute at 40 seconds? Straight away, just look from the graph, you'll know it's around 5 or 8. Okay. How far the parachute has fallen from 20 to 60 seconds. This is looking for distance. Okay, in a speed time graph, if I need distance, I only need one thing. AKA, I need area under the graph. So if I ask students to find distance for speed time graph, is actually I'm asking students to find the area under the graph. What graph am I looking at? Is 20 to 60 seconds. 20 to 60 seconds, if you look at the graph, 20 to 60 seconds is from here to here. It is a simple rectangular. So formula will be length times breadth. Okay. So that will be the area of the square or rectangle, sorry. It will be 320 meters. Do not use distance divided by time. We only use distance divided by time for average speed or when the speed is constant. Usually it only happens in where? Sound. Okay, so most of the time, other topics, when you look at distance, we tend to use area under the graph quite often. Okay. Like I mentioned to you, where do I open the where do I, from the graph, you see a few things. Where do I open the parachute? And one of the things that I actually see is where do I locate the parachute with the highest acceleration. So same thing, highest acceleration in the speed time graph. What am I looking at? Is actually the gradient of a speed time graph. Okay, so I want to know the fastest gradient. Fastest acceleration means I want the biggest gradient. Means I want it to be steepest. Okay, for gradient, okay, to find the steepest, you will need to find the tangent of the graph, which happens to be at the beginning of the graph here. So at the beginning of the graph, the tangent to the curve will be the steepest. Okay, the tangent here, this will be the tangent to the graph. This will be the gradient at the point. What point? Time 0. Okay, this will be the steepest. And because it's the steepest, it also means since gradient is the acceleration, since it's the steepest gradient or what I call the biggest accelerations, okay, this will be the answer for part 4. Okay, and like I mentioned before, describe the gradient parachute at 60 seconds. Okay, you stop, it landed already. Okay, quite an easy one. Okay, the hard part for this question is actually to analyze the graph. Okay, to pack the graph to the motion of the parachutist. Part C, dangerous to use. Slide is like an off-tangent question. Okay, it's a different question. Okay, why is it dangerous for you to slide? Okay, I would say it's a quite common sense question. Okay, because the question says wet, and it mentioned, and from the question you know that wet usually has everything to do with friction. Okay, so that's why I know the friction, it will be little. Okay, take note of the word little and no. Okay, little means there is reduced, there is still a bit of friction. No friction. Okay, no friction usually in real life, we don't look at ideal cases, or we have keywords like when we use the word smooth. Right, smooth, it literally means like no friction. Okay, so take note of what you are writing. Okay, do not exaggerate the impact. Okay, so that's why the use of little is important. Okay, so after that, it will be like a common sense question. If it's too little friction, the speed will be super high, and the guy literally will maybe fall out of the safety zone, etc., etc. Okay, now with this, okay, this will be the last question of the Hillgrove Secondary School. Okay, I repeat again, if you have not tried the paper, okay, remember to go and try the paper. Okay, if you need the paper, it's down at my description panel there. Okay, the Google Drive. Okay, if you need anything, okay, if I have explained anything wrongly or you need more explanation at a certain part of the paper, just drop me a comments. Okay, I'll be going through other papers also. If you need, once I uploaded, okay, I will let you all know again. Okay, if you have, if you want to get the notifications, remember to subscribe to the channel and remember to press the bell button so that you will be informed whenever I upload the paper, and hopefully that the paper will be of interest to you. Okay, if not, okay, thank you very much. Bye-bye.